So with that one, welcome to the sixth synchronous learning session. So we're going to focus on introduction to in-betweening. So all of the concepts that you'll be needing for the process of in-betweening will be done right here in this lesson. The next few lessons, I think for module 7, it's um, how you're going to use compositing tools. Module 8 and module 9 is for favors and thirds, and then the 10th one is the actual application. So with that one, let's focus on introduction to the concepts itself. So with this one, we have quite a lot to focus on. For these ones, these are mostly just concepts that you'll have to think about when you're going to do in betweening. So a lot of the terms that we'll be focusing on today will only have value later on when we do the activities. So with that one, just take note of these ones. You don't have to think so much about them. But if you can find practical applications of it later on when you're probably watching some animations, then it would be something to look out for. So let's have first the definition of in-betweening. So in-betweening can be spelled in a number of ways. So the one that I'll be using is the one that is approved by DepEd and TESDA, which is IN with a dash in between IN and then betweening. So in-betweening, also known as tweening for digital animation, is basically the process of rough intermediate frames between keyframes. So basically, you have your two keyframes, which you have probably cleaned up, and then you're going to create the frames in between them. That's why it's called in-betweening. So really important for here is that for the in-betweening process, number one, it's usually rough drawing. So there is a possibility for you as an in-betweener to have another cleanup artist. However, for more modern animations or for more animation studios that tend to have like around less than 50 people, a lot of the times is that the in-betweener will also be expected to do their own cleanup. So that's why we have these two skills hand in hand together, cleanup and then in-betweening. So the purpose of in-betweening, of course, is mostly to give the illusion of smooth movement. Next one is we have the in-betweener, which is the persons in charge of drawing the in-betweens. So usually this is an entry-level position. So this is also usually the training ground. So like let's say if you want to be a senior animator, if you want to be a storyboard artist, concept artist, you have to know the idea first of animation, and usually you can get that training through the use of becoming an in-betweener. Cleanup artists, yes, it's possible for them to be ascending to the different ranks since basically they have an idea of movement, but this is a more direct application of movement, whereas for cleanup you're basically following the steps of what the in-betweener or the keyframe animator has done for you. So with that one, um as stated, in smaller animation studios or in more modern animation studios that utilizes traditional animation, usually the in-betweener is also expected to do their own cleanup. So we have here the qualities of an in-betweener. The important thing that I'd like you to understand is that when you're an in-betweener, you don't really have to be good at drawing. I think that was stated very early on, that when you're animating, it's more of about the motion itself. So understanding how the movement works, the physics regarding movement. So a lot of the things that I'll be talking about here, like let's say the laws of motion, speed, velocity, acceleration, gravity, and so on and so forth, are some things that you will be that I will be stating. So with that one, I would really suggest for you to have an idea or to try and review these terminologies, particularly in terms of the physics of motion. Another one is observational skills. So observational skills come hand in hand with how you would develop your understanding of movement. So for you to understand how movement works, you'll have to observe real life situations. So like let's say since we're all in quarantine, you can basically watch your housemates or like let's say other people around you, how they walk, how they do actions. So probably you might want to look at them at a nearer place. So like let's say literally in front of you. You can also see the same movement at a distance. So like let's say when someone's walking in front of you, you can very clearly see a lot of the movement that's happening. However, if you see someone walking within the distance, like let's say through your window, you might see that there is not a lot of movement, or even like let's say how the timing would happen is quite different between how the distance between the viewer is. So with that one, observational skills is the way for you to understand how movement works. So how do you do this as a beginner animator? So the easiest way for you to develop observational skills is for you to watch a lot of animations. And it's not just about watching the animations, it's about pausing the animations frame by frame for you to actually see how the movement works. Because a lot of the times is that, of course, you will be creating illusions. So how you're going to create those illusions is possible by observational skills. Another one is for you to try and do it through photography. So it's not about creating a good image, but it's more of about taking an image of the person doing an action in the moment. So expectedly, what you will be seeing right there is a lot of blurry shots, which is quite expected because your camera can't really pick up a lot of things very clearly. So with that one, that would actually help you create your idea of how to do animation blurs later on, and even for squash and stretch necessary for in-betweening. So again, good illustration is a secondary skill. So it is possible for you to be a good illustrator, but not necessarily a good animator. A lot of in-betweeners or a lot of animators, they don't really come from illustrator backgrounds. So with that one, they tend to be draftsmen o kaya naman other fields of life. So for example, Walt Disney was a draftsman and he was able to understand the idea of motion, not necessarily because he was an illustrator, but he was more of a draftsman. So with that one, it's not about learning how to draw beautifully, but it's more of drawing enough for you to be able to create the motion. Because as stated kanina, a lot of the things in betweening, you will only be seeing it within a fraction of a second. So like let's say if you create a lot of detail in betweening, it's number one pretty useless because it won't be seen. Number two is that it would actually affect the quality of your animation. So to give you a better example of this one is we have an illustration right here of a falling basketball. So for those who are using their PDF versions, please come back to the live stream. So you have right here in different frames. So you have 24 frames per second, 30 frames per second, and then 60 frames per second. So with this one, probably when you're doing a lot of games or when you're playing a lot of games, a lot of importance goes with refresh rate. So you have 60 FPS. The reason for that one is more of response time. So for example, if you have clicked on something, you kind of expect the game to also respond to the same time as you. So with that one, the 60 FPS is becoming quickly the new standard for gaming. However, for animation, you don't really need that 60 FPS. So you can see quite a lot of things in, let's say, the Netscape or on the internet, wherein a lot of these traditional animations or a lot of these slower animations for 24 FPS is turned to 60 FPS. So the results are very jarring. So you can almost see it right here. So for the 24 FPS, that's the one that we need when we're animating, because most of the time you would rely on those blurry things, which is your animation blurs. Whereas for 60 FPS, you can kind of see that there is a clear distinction from frame to frame because they're very clear. So with that one, it's much more unnatural for you to use the 60 FPS compared to that of the 24 FPS. So, however, when you're a modeling or when you're an in-betweener, it's still important for you to have the modeling, but it's only secondary. So, we have here some examples of how incorrect modeling, more on in-betweening, not so much on modeling. So, excuse me for a while. Alright, sorry about that. So, here we have also some skills in in-betweening going back. It's just a short reminder of what you're supposed to look after. Next one we have here measurements in animation. So for the measurements in animation, this is something that's important for you to understand that the term for frame, drawing, and feet is very different. So like let's say we have the term frame. So frame is something more for a renderer or for a render wrangler. So as an animator, this doesn't necessarily matter to you, but it's more of the frame rate that we're going to use. So for animation, we tend to use 24 frames per second. So it's possible for you to have like let's say 12 drawings and then render it to 24 frames per second. it's another story if, like, let's say you have 60 drawings and then you turn it to 24 frames per second, or even like let's say you have 24 frames or 24 drawings which will be turned to 30 frames per second, which is the standard frame rate for live action game. I mean for live action videos. So with that one, it would be something more for the renderer to think about. However, as an animator, the only thing that you need to know is that 24 frames per second is the standard frame rate in an animation. So we also have other examples. So we have 60 FPS, which I've stated is usually the emerging standard frame rate for video games and also for 3D animation. And then we have the really ridiculous ones, the one with the slow motion cameras, which is mostly the standard is around 10,000 FPS. Next one we have the term drawing. So the term frame is more for the renderer. So for us animators, we just need to know that it's 24 frames per second. As animators, however, dito na tayo nagkakaroon ng difference. So for the drawing, this is the actual number of images that what you're going to do when you're going to do keyframing and then in-betweening. So for the number of drawings that you'll be using, you need to have different methods of timing, which will be explained later on at the bottom. Next one is we have foot or footage. So probably later on when you're going to encounter these ones in a very traditional animation setting, you need to know that foot or footage is usually an earlier measurement of productivity. So we have here different units of measure. So like let's say if you've created 12 frames, then you have created 0.75 feet of progress. So it's more of determining progress. This is also the way that how animators were paid before then. So it's more of the feet. I think for now, in Japanese animation standard, they are usually paid per frame or per drawing. For Western animation, they tend to have more consistent pay. So like let's say regardless if you've done 12 or you've done 24, the pay rate is still the same. So here we have also different units of measurements for animation, but for you to truly understand this, we'll have to move on to the methods of timing. So the methods of timing is how many drawings that you'll be using to create 1 second. So as an animator, this is something that we have to care about because this will dictate the fluidity of your action. So it's also possible for you to have one method of timing within 2 keyframes. So an example of this one is a movie called Akira, which is one of the prominent examples of animation in Japanese animation. The reason for that one is because it's stated that they are animating in ones, which is not necessarily accurate because what would happen is that they are primarily animating in ones, but they can also animate in twos and threes and fours whenever the action is necessary. So we have the standard in the industry is that we can animate in ones, twos, or threes. So yung force natin is not really something that we use as much. So you only use it for very specific situations if you really want your actions to be more robotic, more crisp, and so on and so forth. So here we have different factors on how you're going to determine the method of timing. A lot of these ones usually come from experience, but here are just some factors. So number one is speed, fluidity of movement, impact of the sequence, overall preference of the animation studio, and also project restraints. So project restraints is actually the number one factor in determining the method of timing. So for example, ones is the most expensive one, which will be you'll learn later, which is usually used for Disney animation. So Disney animations tends to have a lot more budget, so they have the liberty to use ones. Twos is mostly used for Warner Brothers, Hanna-Barbera. So the context right here is that for Looney Tunes, Hanna-Barbera, all of those animations came after World War II. So you're still in that idea of post-war financial struggles, like financial constraints. So with that one, you have twos, which is it kind of doesn't have that much difference if you execute it properly. However, it takes up a lot more budget. And we have threes, which is mostly used for Japanese animation. Budget is also a factor, but the biggest factor right here is the time. So for example, probably you've seen this before, wherein if a Japanese animation wants a new season, usually the fans want it as early as possible. So with that one, you need to use as less frames as possible, that and you would still be able to allow much more movement. So with that one, we have the ones, twos, and threes. So we can have fours, fives, but it's not really recommended. So the first one is ones. So ones is basically you're going to utilize 24 drawings per second. So 1/24th of a second, you'll be using 24 drawings. So what would happen right here is that when you're a renderer, you won't be able to do much conversion. So walang mawawala in terms of your quality when you're going to use one's animation. So one's is the one that creates the smoothest animation amongst all methods of timing, because you tend to have more frames to work on, more subtle changes, whereas where you're using twos and threes, the changes in the movement can be much more obvious. So this is also recommended for high-paced scenes and mostly seen in older Disney films. So for example, we have of course the earliest one, which is Steamboat Willie. So this is also an example of why once isn't necessarily a standard, or like let's say it's not really the magnum opus type of method that you're going to use. The reason being, if you only use once consistently, you would get this kind of motion that looks very bland. So with that one, there's no difference in the animation, there's no variety in the animation. So with that one, it's not really ideal for you to use once constantly. And then as I've stated, Akira, since it's an action movie, they would prioritize mostly animating in ones. Twos is the standard that we have today. So twos utilizes 12 drawings per second. So it's literally half of what the ones use. So if you're going to convert from ones to twos, the budget is literally divided into half. The time is divided into half. So you can kind of see the appeal for that one. So you can create still a very nice movement compared to that of threes or fours, but the difference between the ones and twos can be almost indistinguishable if you're going to use other techniques to bridge gaps, usually like let's say animation smears or animation blurs. So examples is we have Looney Tunes. So you can see a lot of these action lines, so these blurs right here, which would help create this more dynamic movement. So it's kind of like similar right here. So if your eye is a bit trained, you can kind of see the difference between using ones and twos. But generally for an audience that doesn't that is just there to watch your animation, they won't really see the difference between when you're going to use twos with animation blurs and ones without animation blurs. We also have here an example of twos animation for Adventure Time, and they don't use any smears. So it kind of has the same idea of 60 frames per second, is that when you don't use smears is that the movement seems slower even though the timing is considered as fast. And then lastly, we have the threes. So threes is 8 drawings per second. So you can kind of just, ang clue natin dito is for you to divide how many for you to attain how many drawings you need, you just have to divide the frame rate compared to that of the numbering right here. So for example, for you to know how many drawings you'll need to use for one's animation, you just need to divide 24 by 1. If you want to use two's animation, just divide 24 by 2, which is 12 drawings. And then for three's animation, divide 24 by 3, and then you have their 8 drawings per second. So this is the one that we mostly use for Japanese animation. So you can kind of see that there is some difference between Japanese and Western animation because of how the method of timing is used. So for three's animation, they tend to be slower, more choppy. So because of budget and time restraints, what would happen is that even though that they're doing a lot of action scenes, they would still use threes. So you can see it right here in Dragon Ball Z and very famously in JoJo's Bizarre Adventure. So if you kind of just watch this really closely, a lot of the things that they use are still shots. So even though that it's an action-packed animation, you don't really see a lot of very fluid action. So it's more of these types of action that utilizes a lot of animation blurs or even just repeating movements. So if you're going to break this down, you essentially just have a few frames. So probably you only need 3 frames and then you're just panning it a bit upwards. So with that one, as an animator or as an animation studio, it takes up much less resources for you to do it. So that is for some ideas on in-betweening. Now let's move on to time charts or timing charts. So this is the really important part, because for you to be able to create in-betweening, you'll need to have an idea of what timing charts are. So time chart is the one that indicates the number of in-betweens between your two keyframes. So usually we don't really use exposure sheets anymore. We tend to use time charts as the primary source of how we're going to do the in-betweening process. So this is usually dictated by the senior animator, and as a senior animator, usually you would be the one who will be dictating the time chart. So it's used to determine a lot of things. Number one is the number of in-betweens, the method of timing, if you're animating in ones, twos, or threes. We also have the types of timing if you're going to use thirds and favors, which will be discussed a little bit later. It can also indicate the speed. So again, if you have lesser drawings, you can create a faster action. If you have more drawings, you tend to have a slower action. And it's also used for you to break up a more complicated action. So later on, you'll be seeing in the examples below that this really long keyframe or this really long time chart can be divided into smaller time charts, which can then which are then temporary and can be used for you to guide yourself in creating an animation or for you to be able to create the in-betweening process. Now let's move on to how you're going to write it. So depending on your animation studio, this would depend on how you would write it. So like let's say for more Western animation, they tend traditional Western animation uses the one that we'll be utilizing today. For more modern or independent Western animations and even for Japanese animations, the lines tend to be straight lines, and then they have other ways of how they're going to write their frame number. So as you've experienced for your modules 4 and 5, we have one letter and then we have one number for the keyframes. So we have the reading orientation. The one that we'll be using is from top to bottom. The line drawing, again, you can use a straight line, but for us, we'll mostly be using a curved line. So you can use any type of curved line actually, but the one that I'll be using is more of this type of orientation. So it's more of a reverse S rather than that of an actual S. So however, it's possible for me to also use the others depending on which is more comfortable when drawing later on. Next one is for frame label. So this is something again that was seen that you've seen for quite some time. So the one in your module 4 and 5 uses a 1 and a 3. So you have your letter right here, which usually indicates the shot of a scene, and then we also have the keyframe right here. However, for a lot of the examples that I'll be showing you and for a lot of the activities that we'll be creating later on, you don't really need the shot label, which is the letter. We only need the numbers right here. Next one is the method of timing. So for the method of timing, usually the numbers are written in multiples to determine their method of timing. So if you're going to see the interventions between it, you can kind of see how it's going to be created. So for example, if you're going to animate on ones, usually you would have just a normal counting. So you always start at 1, you don't really start at 0, the very first keyframe. But it's possible for one keyframe to not be 1. So as you might have seen before, for your module 4, that's A4, which is a keyframe. And we have A10 for module 5, which is another keyframe. But usually the start of the shot should be at 1, and then it will just continue on later with further keyframes. But anyway, so you always you have your first keyframe right here, and usually there would be only multiples of 1. If you're going to use 2s, you can kind of see that from 1, it kind of skips to 3, and then afterward it skips to 5 and then to 7. So you kind of leave out the even numbers, so your 2, 4, 6, for you to indicate your 2s. For 3s naman, from 1, you can kind of see it moves from 4, which is, it skips 2 numbers. You have your 2 and 3 skipped. And then from 4 to 7, you have your 5 and 6 skipped. So that's more for 3s. It is also possible for one keyframe to have more than one type of method of timing. So for example, you have 1, and then the next in between right here is 3. So you don't really see where the 2 is, but you can kind of determine that this is a 2's. But when you move from 3 to the next in between, you have 4, which is 1's. And then from 4 to 5, you also have 1's right here. So it depends on what on what the keyframe artist believes is more appropriate, on what type of method of timing that they'll be using. So it's possible for them to have multiple they can have 1's, 2's, and 3's in one keyframe if they would really like to, or if the action is more complicated. So if the action is more complicated, it's possible for you to break it down into sections, which will be shown later on how you're going to create your animation. And then we have the distancing of the frames. So you might have seen this before. So you have your curved lines right here. So your curved lines will determine the distancing between them. So equal spacing means that they have equal speed. We also have here the parts. So for the parts, you have 3 main parts. So the first one is your keyframes or extremes, which is highlighted in a circle right here, and they're usually the start and the finishing frames. We also have a breakdown. So your breakdown is a specialized in-between. This can be dictated either by the keyframe artist or by the in-betweener themselves. So this is usually the middlemost in-between, and it's used for you to further break down the keyframe. So you can then turn this timing chart into 2 separate keyframes. So you have from 1 to 4, and then from 4 to 7. And then lastly, of course, you have the in-betweens, which are the intermediate frames between the 2 keyframes, the one that you will be doing animation on. And then nextly, we have our favors and thirds. So favors and thirds is how you're going to determine the spacing. So it's more of how, this is actually one of the things that would really impact your animation, whether you're animating in thirds or whether you're animating in favors. So let's go for the easiest one first. So essentially, the distance between the keyframes or the distance between the in-betweens would determine the speed. So if they're closer to each other, that would mean that the distance is slower. But if there is lesser space between the keyframes, then that would determine a faster action. So thirds tend to have equal spacing. And if there's equal spacing, it means that there's constant speed. So here we have sample applications. So you have your walk cycle, run cycle, mechanical movements, aroma and smoke, which is an example of whip and wave principle. Just something to remind you of. Your final project will be a unique walk cycle like this. Not necessarily like you have all of the frames right here that was stated, but you will have to create your own unique walk cycle. So if you you might kind of see this, but how we walk is very different from person to person. So you'll be creating your own character, and then you'll be creating how that character walks. We also have here a run cycle, which is an iteration of the walk cycle. We have mechanical movements like robot arms, and other things. We have aroma and smoke, so this usually moves on at a more consistent speed. We have wave principle, so this is a specific type of concept in animation. And we also have here whip principle, which is also usually in thirds. And any type of movement that can be done at a constant speed is considered in thirds. Like let's say batting eyelashes. Unless your batting eyelashes tends to have more emphasis in terms of speed, then that would be in favors. But usually the batting eyelashes is on thirds. And then the skip cycle, the movement tends to be at a constant speed, so it's also in thirds. So anything that's in a constant speed is usually in thirds. And now we have the favors, which is a bit more complicated, but this is something that you have to know more since a lot of the movements that we have tend to be more of favor. So a lot of organic or human motions would follow a favors type of timing. So it can either show one of 3 things. So the first one is it can show a slow out, it can show a slow in, and you can show a slow in and slow out. So if you can kind of see right here for acceleration, acceleration basically means you start at a slow speed and then you become faster as time goes by. So you can kind of see that one reflected right here. So from the first keyframe, you can kind of see that the distance between 1 and 2 and 2 and 3 are a bit slower. And then from that point on, the distance between 3 and 4, it has doubled in spacing. So you can kind of see that the speed has doubled from 2 to 3, and then 3 to 4. It's double the speed. Even more for 4 to 5. So it's almost the same distance between 1 and 4, and then 4, 4, and 5. And then you have 5 to 6, which is essentially half of the entire keyframe. Then you've really seen that the action has gone faster and much faster. Deceleration is the opposite. So from a fast movement, it goes slower and slower. So you can kind of see that there are more drawings at the very end compared to that at the very beginning. The one that we commonly use is slow in and slow out. So for slow in and slow out, you start off with slow drawings, and then it becomes faster at the middle. And then once it moves towards the middle, it becomes slower and slower again. So what this does is that it gives more emphasis on the keyframes at the top and at the bottom right here. Because if you add a lot more keyframes at the center, what would happen is that there would be more emphasis on the breakdown. And for the breakdown, technically it's still an in-between. So you don't really place so much emphasis on the in-betweens. The in-betweens are made to accentuate the keyframes actually. So with that one, you tend to see a lot more movement in terms of near the keyframes. Here we have sample application. So most of the time, any organic movements is, you can kind of assume that they are in favors unless they're at a constant speed. So like let's say head turns. So head turns is something that you will be creating by around module 8. Facial expressions change. So that emphasis from moving from a fast motion to a slow motion or vice versa. We also have a jump cycle. So for jump cycle, this mostly takes into consideration the idea of free fall. So for example, when you're moving towards the very top or the highest point, it becomes slower. And as you go down or as you go up, then it usually has a much faster motion. And any type of human action really tends to be automatically favors unless it's at a constant speed. So for example, hitting a baseball. So you can kind of see that the actual swing starts slower and then suddenly it gets faster. It kind of shows that skill or that virtuosity from the baseball player, and then that slower swing from, like let's say, from the base up until the shoulder. So what that creates is the idea of anticipation. So having a slower anticipation and then a fast take would emphasize the main action even more. So when you're not using favors like the one that we have here, this is kind of like a cheat since this kind of has more foreshortening or more perspective. So with that one, it's quite unfair to give this an idea for not using favors. But anyway, if you're going to assume that this is a constant distance, you can kind of see the appeal is not that interesting. So you can kind of see that the ball isn't really that fast, even though it's supposed to be. So with that one, not having favors makes the action or makes organic actions not so realistic and not so enticing. And any type of action sequence needs to have favors to have that type of texture. So the last part right here is the concepts of in-betweening. So the first one is the parts of action. So you have 5. The first one is the starting action, which is also known as the neutral, which is usually the first keyframe, and it has the most amount of potential energy and the least amount of kinetic energy. Anticipation, as you've known, this is the preparation before the main action, or also known as the take. So the take is the main action, wherein you utilize a lot of action. So the take utilizes the most energy. Your anticipation is kind of like the way for you to turn your potential energy into kinetic energy, for you to have this very burst of action of energy. And then the overshoot is a type of anticipation. So you have your anticipation, and then after your anticipation, you have your overshoot. But your overshoot is quite different. It's not like, let's say, your starting position and your keyframe to be the same. Usually your your overshoot is a hyperextension of the action. So how much you've extended right here in terms of the anticipation, you should extend a lot more later on when you're doing overshoot. So overshoot is a hyperextension of the action. This is usually a stretch much more than the normal anticipation that we have. And the main purpose of the overshoot is to allow recovery from a high energy take. Because what would happen is that if you have a high energy take and then suddenly you kind of go to this normal starting position, what would happen is that the energy doesn't go anywhere. So let's say, imagine a jump cycle, like a jump like this, tapos you won't be able to land on your feet. Tendency is that you would fall over when you stand. O kaya naman, you won't be able to get the landing at all if you don't have any overshoot. So that overshoot is an opportunity for you to kind of recover yourself before you're actually going to go into position again. So we have an example of overshoot right here. So you can kind of think about it this way. So for those who are using their PDF, you can also refer to the GIF version. So if you're going to see the one without overshoot, it just kind of goes back to its settle, which is the final action. Overshoot is again a hyperextension. So you kind of go beyond first before you move on to the settle position. So like let's say think about it as the third law of motion. So this is called the reaction stage. So like let's say if you want to animate someone like let's say using a gun, you need to have that kind of reaction. So that reaction is kind of like the overshoot before the user can go back to the normal shooting position. And then we have, of course, the settle, which is the final keyframe. We have also the idea of cycle animation. So a lot of the animations that we'll be doing is a cycle animation. So the idea of cycle animation is that you can kind of create it on a loop. So for you to be able to create it on a loop, you have to make sure that the starting position and then the keyframe and then the settle position has to be the same idea. So the jump cycle right here, you can kind of turn it into a loop. But as you can see right here, the distance has to be considered. So for you to be able to turn it into a cycle, what you would want to do is to jump from left to right. Let your character turn towards the settle and then jump again from right to left, turn them again, for you to be able to create that cycle. One thing that you can do in order to also make sure that it's a cycle animation is that usually the character doesn't move in terms of length, in terms of horizontal. They just only tend to move at a vertical motion. So with that one, you can also use that as a basis. If ever they move from a horizontal frame, in a horizontal frame, what would happen is that they would go back to its original position. So we have different examples right here, like walk cycle, run cycle, jump cycle. So non-moving, ibig sabihin you're using like free fall, the idea of free fall, skip cycle, and then wave principle. Nextly, we have separation. So separation is an animation technique. So this is more for in-betweeners. We've had a little bit of an idea of this one when we were doing our cleanup for in-betweening. So the tracing idea right there is something that you have to take into consideration for separation. So the idea of separation is that you're going to separate the moving items from the non-moving items. So the idea right here is that you're going to isolate the moving items, identify them, animate them separately on another paper, and then take another paper and then create the non-moving objects and then use this one to trace it over the frames where you've created the moving objects for you to have lesser modeling. So with that one, the idea of tracing right here is more of an animation technique rather than that of a cheat. You can also kind of call it as a cheat, but if there's no movement in terms of the modeling, then it would be much more practical for you to do this. So examples of separation. This is a more complex type of separation. So you can kind of see that the character's head is tilting slightly, but for the hair, everything else except for the eyes and then the mouth, it's not moving. So with that one, you would kind of tilt it towards the left side for you to be able to create this idea of separation. So basically, you're still tracing the hair, the head, everything, but what you would be doing is that you're tilting it towards the side to kind of give it more motion. Next one is we have unexaggerated talking. So this is more for Japanese animation, so it's a way for them to save much more budget, because if they were to take into consideration the chin right here, they would have to animate much more. That would take much more time and, of course, more resources. And then for dancing, more like, let's say, less fluid type of dancing, like let's say this quote unquote white people dance, you can just create separation. So you can just isolate the limbs right here, but the main torso kind of stays the same as well. And another one is for flowing or blowing hair. You can just kind of make the face separate, whereas everything else for the hair tends to move. We also have here the idea of imaginary drawings. So the imaginary drawings is a technique in animation that imagines a non-existing drawing in between two separate ones. So this is a way for you to kind of project yourself or kind of project the idea of how you're going to do animation. A lot of the times right here is that the imaginary drawings is used for twos and threes because it's not very practical for you to use it in ones because a lot of the action in ones is more subtle. So tendency is that you will have to draw the imaginary drawing anyway. Next is we have offset. So for offset, it's used with overlapping action. So when you do a full body turn or when an object changes direction, not everything changes at the same time. So of course you have your secondary action, but more importantly, it's more of how you turn your body. So for example, when you're going to turn, if you create an actual full body turn where all of your body parts would kind of move at the same time, it would look a bit more robotic. But like let's say you start to move your head first and then your torso and then your legs, it kind of makes more of a fluid, more human motion. So you have here a twirling ballerina. So this would be more of concentrating on the views in terms of how it moves. So with that one, you would need the idea of separation right here. So you would have to create the head first and then the body and then afterwards the legs. So for example, right here, we kind of started with a normal position. So it's more of, or even right here, it's kind of everything is at the front, kind of. But you can see that the head is facing towards the left. The torso is facing, the head is facing towards the right. The torso is facing towards the left. And then your legs right here is facing front. Not even one of them is also facing front. One of them is facing towards the left. And then as you move on, you can kind of see that there is a difference. Like for example, the head tends to start off first. So like let's say everything is at a back view right now, but the head is at a side view. And then we have right here yung back natin or the torso, which is fully in back view. And then you have your left leg right here, which is kind of lagging behind. So it's 3/4 view back. It's not entirely back. And then, of course, you have your hair right here, which kind of follows the idea of overlapping action as well. And then we have different applications of offset. So it's more of twirling bodies. We also have your drag. So drag is used for secondary action. So the idea of trailing, the trailing of soft material. So like let's say hair, flesh, cloth, all of those things can be used to trail soft material. So if the action doesn't move, of course, the drag doesn't really occur. So different examples of drag is you have hair movements. It has to trail behind. Clothing movement, if like let's say you're walking, it has to go behind you. And then for flesh movement, any type of movement that is more flesh. So like let's say back fat, the tail right here, jowls, longer ears, all of those ones can be used as flesh movement and then can be used for drag. Lastly, we have animation blurs. So for animation blurs or animation smears, this is mostly used for animating in twos and threes. So this is kind of like the cheat that you would use to make sure that your twos is also having the same quality as your ones. So we have right here different examples that you can look into. So with that one, sorry, for a while now. Anyway, so you have here different types of animation blurs that you can consider. So it depends on you or it depends on the style of the animation studio. It depends on your own style, what type of animation smear that you would like to do. I'm not really going to dictate a certain type of action speed or action line that you might want to use. However, it is much more recommended that you have a combination. So you have speed lines, multiple exposure. For this one, you have simple speed lines and multiple exposure as well. And then the very last part is we have the process of in-betweening for thirds and favors. So for the thirds, it's quite easy. Essentially, what you're going to do, an important part right here is the distancing. So from your first keyframe and then the last keyframe, you have to determine how the action would move. And then how the action would move would be considered as the path of action. So more of the distance as well. And you also have to take note of if ever it's going to rotate, you'll have to determine what type of rotation it will be, clockwise or counterclockwise. Also the direction, left to right to left, up to down, all of those things have to be considered as well. Next one is the path of action is really important because you will have to use it to divide the spacing. So this is applicable for both thirds and favors. But for thirds, this is really important since you can simply use this one as your basis. So you don't really have to do post-to-post animation. However, it is recommended regardless whether you're doing thirds or favors. So once you have set up the spacing or the division of the spacing, really important right here is that for the path of spacing, it has to be at the center point. If you can find a center point, or if you can't find the center point, find an anchor where it's going to be wherein you're going to consider. So like let's say when you're going to use a pointing finger, your anchor point won't necessarily be on the hand, but it's more of the tip of the finger. For this one, since we're creating a ball, it would be much more appropriate for us to use the center of the ball as its anchor. And then, using that one, the spacing, you can then use that to draw the in-between. Again, take note of the anchor. Also take note of the detailing. So for the detailing, you'll have to find the middle point. That's why this was considered in terms of finding the direction. So it's going counterclockwise. So from like, let's say this, sabihin na natin 90-degree angle to 0-degree angle. Yung gitna niya is a 45-degree angle towards the right. So yun yung ginawa natin. For the two naman, again, you will have to take note of the spacing, find the anchor. Whereas for the detailing, you need to find the middle of this 90-degree and this 45-degree. So that's 67.5. So the degree right here is 67.5. And then lastly, we have for the number 4 right here, which is the middle of 3 and 5. So for this one, you can kind of use the spacing right here as well. Don't forget the anchor as well as the detailing right here, which is 22.5, the middle of the 0 degrees and then the 45 degrees right here. And then here we have the final output for the placement of the in-betweens. So we have the GIF version right here. So if you're using your Canvas account, you can kind of see the movement right here. Next one is we have for the favors. So the favors, the one that I've used as an example is a circle pendulum. So if this were a bit slower, you can kind of see the motion of it. But if you try to stare on it a bit longer, you can kind of see that the motion at the start and at the end tends to be much slower. Whereas for this one, it tends to be a bit faster. So make sure that you have your keyframes and of course your timing chart. So for this one, this is an example of a slow in, slow out. So at the very beginning and at the very end, there tends to be more drawings. And then at the middle, there's not really a lot of drawings. Again, please take note of the path of action. So if you can kind of see the path of action right here, it's not a straight line. So a lot of the path of actions that we have is more of a curved line since a lot of our actions are more organic. So with this one, nagawa tong semicircle na to because of the length of the string right here. It would be impractical for you to kind of create a curved line na kind of right here because you're not considering the length of the string. So how I was able to create this is that I actually did this step first and then I started to trace. So that's how you kind of determine it. And then again, this is an example of post-to-post animation. Since we don't really have a lot of time, I'd like you to please look at this one on your own. But essentially, what you're doing is that once you've created one of the in-betweens, you use that in-between as its new keyframe. So as you can see right here, I've created a new timing chart or a new time chart. So this is something that you won't be using. However, as an in-betweener, as a beginner in-betweener, it might be something that's useful for you. So, you find the middlemost part again, which is 3. So, lalagay mo ulit sa gitna nila in terms of the path of action. Turn that 3 into a new keyframe. And then from that point on, you will be creating your 2. So you kind of do this action until every single part of the first half has been drawn. And then you kind of do the same process on the second half. So the idea right here is that when you're going to analyze your time chart, you have to create the keyframe first that has the lesser drawing. So if you're going to create the first half, you start off by drawing the 4, and then the 3, and then the 2. Whereas for the second half, you don't really start creating the 6. You start creating the 5 first before creating the 6 in between. So those are just some ideas of how you can do in-betweening. Last thing that you have to consider is the videos right here. So for those who have Canvas accounts, I have linked here 4 videos on how to give you an idea of how in-betweening would work. So with this one, I'd like you to get some idea. Try and watch all of these ones. For those na walang Canvas accounts, I'll try to link up these ones as well. So that ends yung sa may discussion natin. If you have any more questions, please let me know using yung sa may text channels natin. But if you don't have any more questions, then probably we can end right here. So with that one, thank you so much for coming in for today. I hope you were able to learn some idea of in-betweening. If ever you have any more questions, please let me know using the Ani12a text chat o kaya naman your text channel for your own section. With that one, thank you so much and have a nice day.